Good afternoon, everyone. Today is the session 11 from the chapter of electric charges and fields. The topic is motion of a charge in an electric field. And here I have drawn one diagram. Uh, in this diagram, I have considered the Cartesian frame of reference. That is, this O is the point of origin. This is the x-axis and this is the y-axis. And a charge of a magnitude q and of mass m, it enters this region of electric field along the x-axis, and the direction of this electric field is perpendicular to the direction of motion of this charge. The charge enters this region of electric field with a constant speed of u along the x-axis. So this is the point of origin, this is the x-axis and this is the y-axis. The direction of the electric field is along the y-axis in the upward direction, and the charge is moving along the x-axis. That is, it enters this region of electric field at this point O along the x-axis with a constant speed of u. So now when this charge enters this region of electric field, whose direction is perpendicular to the direction of motion of the charge. So in that case, this charge will experience an electrostatic force whose direction will also be the direction of the electric field. That is, the electrostatic force which this charge will be experiencing will be directed upward. Now let us say if this electrostatic force is Fe, then Fe will be equal to Q into E. So this is the magnitude of the electrostatic force, and this is this force will be this charge will be experiencing this electrostatic force in the upward direction, and the direction of this electrostatic force will be the same as that of the direction of this electric field. So because of this electrostatic force, this charge will gain some acceleration in the upward direction. Okay? And because of this electrostatic force, this charge will also follow a trajectory something like this. So in this case, what I will be here we will be first of all finding the deflection of this charge at any moment of time. This is the first deflection of the charge. And we will also try with the help of the formula which we will be getting for the deflection of this charge due to this electrostatic force, we will also find the trajectory of this trajectory of motion of this charge when it enters this region of electric field. So first thing is that we have to find the deflection of the charge. And what is the deflection of the charge means? That is, for example, this is the trajectory which it will be following once it enters the region of electric field. So let us say at this point, so the deflection will be the deflection of the charge will be this. This is the deflection of the charge. Now this is the deflection of the charge, say it is y at any moment of time. So yt is the deflection of the charge at any moment of time, and this is what we are going to calculate. So in this case, the charge enters this region of electric field at this point O with a constant speed of u along the x-axis. So when it enters this region of electric field, it will experience an electrostatic force which will be given by Q into E, and this electrostatic force will generate some acceleration in the charge in the upward direction. So this since force is equal to mass into acceleration, so I will write this Q E is equal to m into A, and from this equation the acceleration of this charge will be equal to QE upon m. So I will write it here. Acceleration of the charge is equal to QE divided by m, where m is the mass of the charge, q is the magnitude of the charge, and E is the intensity of electric field. This is the first equation which we have got. Now, when this charge enters this point O, so at this point, this charge is having a horizontal constant speed of u, but its vertical component is 0. But when it enters this region of electric field, then it will gain some vertical this component of speed. So in that case, because of that, it will be there will be a deflection of this charge from this from its original this direction of motion, and now we have to calculate this deflection, which I have denoted here as yt. So the initial, initial vertical component of velocity at O is 0. The initial vertical component of the velocity of this charge at this point O is 0. Horizontal component, that is it is moving in the constant speed, which is equal to u, and this is the the speed in the x direction. So I will be now using the equation of motion. The equation of motion is, there are three equations of motion, but I will be using the equation of motion which is given by S is equal to ut plus half at square. Now the initial vertical component of the initial vertical component of velocity of this charge at this point O is 0. So this u into t will be equal to 0. S, this is the deflection, which is I have mentioned here as yt, and plus half a. Acceleration is QE by m into t square. So we get the deflection yt as 1 by 2 QE upon m t square. So at any moment of time, if we can calculate the deflection using this equation. Here we know the charge, the magnitude of the charge, we know the intensity of electric field, we know the mass of it. So at any moment of time, you can calculate the deflection of this charge. And what is deflection? That is, it is the the distance between the this direction of motion along the x-axis and that point at a particular moment of time. That is, if this particle is at this position, let us say this is the position A. So, and I'm just mentioning this position as B. So let us say at any moment of time the particle is at a position A, and so the deflection will be equal to this AB. The deflection will be equal to this distance. This is the deflection. And this deflection is given by this equation. That is, yt is equal to half QE divided by m into t square. Now this equation can also be written as, now the horizontal component of this speed along the x-axis of this charge is u. So you can say the distance covered by the charge the distance covered by the charge along the x-axis in time t will be equal to u into t, and if it is say which is equal to x, say, so this is the distance covered by this charge along the x-axis in time t, this is equal to u into t, where u is the constant speed and t is the time. And so I have taken this distance equal to x. So ut is equal to x. So it implies that ut is equal to x. It implies that t will be equal to x upon u. So here I am getting t is equal to x upon u. Sorry, I am just making this as a third equation. This is the second equation. Now substituting this value of t from this equation 3 in equation number 2, I will be getting the displacement, that is yt will be equal to 1 by 2 qe by m, and t is equal to x upon u, so this will be equal to x square upon u square. This is the equation number 4, and we can write this equation as q e divided by 2m u square into x square. So the displacement of this charge at any moment of time is also given by this relation. This is equation number 4. Now from this equation number 4, you can see that q into e divided by 2m u square is a constant, because q, the magnitude of the charge, is constant, the intensity of the electric field is also constant, mass is also constant, and this is the u is the constant speed along the x-axis. So this is a constant value. So it implies that yt is directly proportional to x square. That is, this displacement of this charge is directly proportional to x square, where x is the distance covered by the charge along the x-axis. So since this displacement is directly proportional to x square, we can say that the trajectory of the path of motion, the trajectory of the path of the motion is parabolic. Because this displacement is directly proportional to x square, therefore we can say that the trajectory of the path of motion of this charge in this region of electric field will be parabolic. And this is the case when the charge is entering a region of electric field in a direction perpendicular to the direction of the electric field. So in this case we have got some two important equations. That is, first this is the important equation, that is yt is equal to half in bracket qe divided by m into t square, and the second important equation which we have got is this one, that is the displacement is equal to qe divided by 2m u square into x square. So this is how this is how we can solve this. We can find the the displacement of a charge when it enters an electric field and when the electric field is perpendicular to the direction of motion of the charge. So when the charge enters an electric field whose direction is perpendicular to the direction of motion of the charge, then the trajectory or the path of motion of the charge will be parabolic. So thank you very much for joining in this session, and in the next session I will be taking up a few questions which will be based on this topic. I hope you have understood the concept behind the derivation of these two equations, and so in the next session we will be coming up with some good questions and I will try to take solve a few questions which were asked in the JE examination or in other this engineering entrance examination. So till then, have a nice day. Bye.